Here is an application problem from transformation of functions. The question is, a quadratic function has the equation f of x equals to x minus 3 times x plus 2. Determine the x-intercept for each function, so each of these functions, which are transformed functions of f of x. So, as you can see, we can find the x-intercepts on the original function f of x. So which are, we can write down right here, if f of x is x minus 3 and times x plus 2, then what are the x-intercepts here? X-intercepts are, one is at x equals to 3. So I can write this as 3, 0, right? And the other one is at x equals to minus 2. So that is minus 2 and 0. At x-intercept, y values will be 0, right? So these are the intercepts on f of x. Now the question is, determine the x-intercept for each function given here, right? So we have function y equals to f of 3x, y equals to f of 0.5x, and y equals to f of minus 2x. Now how can we do this? So if you realize, these functions only have one type of translation, and that is horizontal stretch or compression. So that is going to shift the position of your x-intercept in the horizontal direction. So let's see by how much. So if it is f of 3x, then what is the kind of transformation? So every x point will get multiplied by a factor of 1 over 3. It is a compression by a factor of 1 over 3. Do you see that? So that is how we are going to get it. Let me give you a better picture of all this. When we say that the function is kind of like this, so let me draw the function right here, right in the center, so that we will appreciate what we are trying to do. So we have x-intercept at 3, which is here, and at minus 2, which is here. So we can draw our function which is moving up kind of like this, right? So let's say this is our parabola, and these points are, this is minus 2 and that is 3 for us, right? So this is x-axis and this is y. And this is my function f of x. Now when I say f of 3x, what does that mean? It means that this x-intercept, or every point on this graph for that matter, will be compressed by a factor of 1 over 3, right? So that means that this point, which was here at 3, will shrink and come to point here, 3 divided by 3. Similarly, this point will come inside. So the movement will be inside by a factor of 1 over 3. So in the first case, my intercepts, which were at 3 and 0, will actually now be transformed to 3 divided by 3 is 1. So it will be at 1 and 0. And this one will be minus 2 and 0, correct? So in the case of function f of 3x, these are the new locations of the x-intercept. Now let's look into the next one, which is f of 0.5x. 0.5 is like half. So they'll be horizontally stretched. So this will move outside twice away, right? So this will move outside. So this x-intercept will now be at minus 4, and this will be at 3 times 2, 6. That gives us the result here. So we'll have x-intercepts as minus 4, so this is this one, right? And 0, and that one will be 6 and 0. How about this one? In this case, we have two transformations. One is reflection. Remember, it is reflection. So reflection will multiply the x with minus number, and 2, that means we have to multiply the x values by a factor of minus half, right? So in the third case, we are going to get results where x will get multiplied by minus half. So our intercepts will be this one, which is on that side. Let me write here, minus half of 3. So minus 3 over 2x. And that one, minus half, will be minus 1 of 0. So these are the new locations of the x-intercepts for these transformed functions. I hope with this, how horizontal transformation is taking place, especially reflection, stretch and compression, is absolutely clear to you. I hope so. Isn't that? All the best. Thank you. We'll do some more questions like this. Thank you.